Hello, I am Raman Agrawal, and in this video, I will be explaining dynamic programming. Dynamic programming is simply a method for efficiently solving problems. Actually, in programming, what we do is we kind of exchange time with space. Okay, so problems that take longer time to run, we can actually solve them in a shorter time, but using some extra space. Okay, so it is a common practice in programming and designing algorithm to break problems in some small subproblems and then solve those small subproblems. So dynamic programming is basically used for them when solving subproblem, when we have to repeatedly solve some subproblems. Instead of solving them and again, we simply store the result when we first solve the subproblem and then use that result whenever we require to solve the same problem next time. Okay, so let us try to understand it using Fibonacci sequences. You all must be familiar with it, and you might even have written code to calculate fib of n. Okay, so fib of n is basically defined as fib of n minus 1 plus fib of n minus 2, and let us calculate Fibonacci sequence of some numbers. Okay, so I have here a fairly simple code. I have two functions defined here. Let us ignore this one for now. So this function is for calculating fib of n, and you can see it is a fairly simple. N is equals to 0 and n is equals to 1, return 1, else calculate fib of n minus 1, fib of n minus 2. uh, and here are the numbers for which we will be calculating Fibonacci. uh, Let us run it. Okay, so you can see it took really less time for these numbers, and now time is growing kind of exponentially or something like that. It is taking really long time. Here you can see it took 0.4 seconds, and in just 35 it took 5.6 seconds, and fib of 40 is still calculating, and I don't know how much time it will take. Let us wait for some seconds. uh, so actually the thing is it the time required to calculate Fibonacci numbers grows really fast. Okay, so we can use dynamic programming here. uh, so fib of 40 is taking really long time, so let us stop it. Okay, so what happens here is, let us see. Uh, see, while calculating fib of 6, how the recursive calls take place. Okay, so it calls fib of 5 and fib of 4. It calls fib of 5 calls fib of 4, fib of 3, fib of 2, fib of 2, fib of 1, fib of 1, and 0. We can only stop here because these are our base cases. Okay, you can see now. See, let us see how many times a particular call is repeated. So here we call fib of 6, here fib of 5. These two are only one time, but here is fib of 4, and here again is fib of 4. Here is fib of 3, fib of 3, and again fib of 3. Okay, so like if we have calculated fib of 3 here and we store the result, then when recursive call is made here, we can simply look up to the result and use it here. We don't have to calculate it again and again. If here I have calculated fib of 4, I can use it here, and this much time will be saved. Okay, so you can see this is a you know a large percentage of the time that the program will totally take, and it will be saved if I just store the value of fib of 4. Okay, so this is basically dynamic programming. So we store the calculated results of subproblems and use it whenever it is required, like here. Okay, so here I am having the second function, fast fib. Okay, it calculates Fibonacci series really fast. Okay, yeah, you'll really notice and will be amazed. Okay, so here the base case. Now if n is not equals to 1 or 0, so it will first see if I have calculated Fibonacci of n before or not. If I have calculated, it will just return the calculated value, and if I have not yet calculated, it will calculate it and store it in the dictionary. Okay, now let us run it. Let me comment it out and uncomment it. Okay, now let us run it. Oh, you can see that it is really fast. Okay, there we were stuck at 35, and fib of 40 was not even being calculated, and here fib of 120 is calculated in about 0 seconds. Okay, so you can clearly see the difference, and it is actually used in many problems. But let us end it now. I hope you understood it. Thank you.